Abstract problems of area and volume. First problem is that diagram might show the cross-section area of the swimming pool, which is in the shape of trapezium. You can see this is the shape of trapezium. The shallow end of the pool has a depth of 1.2 meter and the pool gradually reaches a depth of 2.5 meter. This is the depth of 1.2 and it is reaches to the depth of 2.5 meter. You can see clearly from the way. As shown in both diagram, the length of the pool is 40 meter and its width is 20 meter, and its length is 20 meter and width is 20 meter. First part is that find the volume of the water required to completely fill the pool. It means that we have to find the water that fill this trapezoid pool. This is another way. There are different ways to find the volume of the water, but I suggest the simplest and easy way, and to just first of all we have to we convert it into a box, into the form of box. How can we see? And so this is your pool, and I want to suggest that you find the median of this depth. Find the median of this depth, and this is the median of your depth. What is the role of the median depth? The role of median depth is the down this region. This is your median depth. This point is your median depth, and this part of the pool you cut from here. You cut out from here and paste here, you can see clearly. Like this one. You cut this. When you cut this and paste it here, and paste it here, and paste it here, then this black color region becomes out throughout, and then you get this hole. You can see clearly. This is your required cube. So we can see that this is your required cube. Now this is your completely cube, and we know how can we find, and the median of this length is 1.85. You know how can we find the volume and area of this cube. First we find the median of the pool. First we find the median length of the pool. How can we that it is very easy. Highest plus lower divided by 2. 2.5 plus 1.2 divided by 2 is equal to 1.85. It means that the median length is 1.85. So this is the cube. This is a complete cube. It is not a trapezoid. We convert our trapezoid to a complete cube with width 20 meter, and the length remains same 40 meter, but its height changes. Height is the height of the cube is just the median of the trapezoid. Median of the trapezoid's height length, depth length, which is equal to 1.85. And so now take the way. Length is equal to this, width is equal to this, and height is this. Volume, you know what is volume. The formula of the volume: length multiplied by width multiplied height, and this will be equal to 1480 meter cube. It is very easy way. It is the very easiest way to find the volume. Okay. Next one, next second part is that float was designed for a water airbags. It consists of two hemisphere. Hemisphere means that half sphere. When we talking about the three-dimensional, then we use the words hemi for the half. For half we use the hemi, but when we talking about in the two-dimensional space, then we use a semi. The word semi for the half. Here, because this is a sphere, you know that is a three-dimensional surface, so that's why you use here hemi. Means that half. So you can clearly see that this is a half, this is a half sphere of the radius 7. Its radius is 7, connected by a cylinder. And take two hemispheres, and one is here, one is here, and it is connected by a cylinder. You can see clearly with the radius, and the radius of the cylinder is 3 centimeter, and the height of the cylinder is 20 centimeter. This the height of this cylinder is 20 centimeter. What we have to do, we have to do find the nearest whole number. It means that we have to round over, maybe we have to round over answer, nearest whole number, the total surface area of floor and the volume of the floor. Now you know better well how can we find the surface area, of floor and volume of a floor. You know what is area and what is volume. I just tell you from the starting that what is area and the volume. Volume and the area is just a space enclosed in the given surface. So this is you have a surface, this is an arbitrary surface, and it is a connection of different surface. So you can separate its parts, and then some of their areas, and that's from where you can get easily area. So we know that hemisphere is here, and hemisphere, it means that two hemisphere, the combination of two hemisphere is we have a complete sphere. It means that, and one cylinder of radius 3, it means that we have this figure contain this surface contain two things, a complete sphere with the radius 7, and a cylinder. Why we call complete? Because hemisphere is here and hemisphere is at the bottom. So when we combine the upper hemisphere and the lower hemisphere, it becomes complete hemisphere with the radius 7. And the cylinder is also separated. So we have to what we have to do for the surface area of the floor, we have to do to find the surface area of the sphere with the radius 7 and the surface area of the cylinder with the radius 3, and then sum their answers, then we get the total surface area of floor. Similar method we adopt for the volume of the floor. Solution, it is clear now. Solution, right? How can we write the clear solution? It is clear that floor contain one cylinder and two hemispheres. The sum of two hemispheres make a complete sphere. It is just I explained in the previous slides from the figure that how is it complete. So we can say that total surface area of a floor is equal to area of a cylinder plus area of sphere, because we see that it's just a connection of two things, a sphere and a cylinder. So when we calculated their area separately and adding them, then we find the total area of the floor. First of all, we calculate the area of cylinder. Here we write down the formula for the area of the cylinder. Surface area of the cylinder is formula is here. Now you know what is pi. 2 multiplied by pi. What is pi? Pi is a fixed quantity whose values is 3.14, and the radius of the cylinder also is given in the statement, which is equal to 3. So putting these values here, and also we know that what is the height of the cylinder. Height of the cylinder is 20 centimeter, which it is given in this statement. And so the answer is 433.32 unit squares. So now next step is to find the area of sphere. The formula for the area of the sphere is here, 4 pi r square. But you know what is the it is given in this statement, and radius of the sphere is 7. So put r at the place of r is equal to 7, and multiply these three terms, we get the answer 615.44. And now total surface area of the floor is equal to area of a cylinder plus area of a sphere. We sum of these two areas, then we get the total area, because it just we just separate, we just divide the floor into two parts. And so final surface area of the floor is 1048.66. Next we have to find the volume of a volume of a floor. It means that volume of sphere plus volume of cylinder. So volume of sphere formula is here. You know what is pi. Pi is a fixed quantity whose value is 3.14, and the what is radius of sphere. R is the radius of sphere. So which is 7. Put 7. So answer is here. After multiplication, answer is this. And volume, the formula for the volume of the cylinder is pi r square h. Putting the values, you know what is the radius, what we have to put here, what we want to put here. Here is we put 3 because 3 is the because r, this r represents the radius of cylinder. Radius of cylinder is 3, so put here 3, and the h is the height of cylinder, which is 20. After multiplication we get this answer, and sum of these two volumes, we get the volume of the floor, which is this. Next question is that it's very easy. Just understand nothing else. Calculate the combined area of a triangle ABC. Where is triangle ABC? A triangle, this A, this C, this B. This means that this triangle A, B and C, and triangle DEF. But where is D, E, and here is F? You I think it's a blur, but here is F. You can see from your documents clearly. First of all, see this diagram very clearly. This is a whole page. Suppose that you have a page of your book, and you want to turn the page of your book. Then how can you turn? You take at the left bottom of your page, and take it up and round it. Similarly, this triangle is the round of this page. That place is missing here. If we turn back, then it complete this field. It completely fill this field. It means that the triangle C ABC is just same like the AZB. It means that the length of AZ is equal to AC, because it's just the fold of this page. This is a complete page from this. When we turn back this triangle to this space, it fill this space. Similar so it means that AZ is equal to AC. You know what is the length of AC is equal to 3. It means that length of AC is equal to 3, and the you know what is the length of Z. Similar ZB, when we turn from here to there, then this length becomes here. It's just a fold of this page, nothing else. When you return this fold back, then it fills this triangle AZB. It is actually a triangle AZB. So the length ZB is equal to length BC. Similarly, you can say that this is also an turn of the from this side of the page. When you turn back this, when you turn back here, the triangle DEF to here DEY at the place of Y, then it fill this place. It becomes when you turn both these triangles, you can get at a page. Then understand this very clearly, that these triangles A, B, C and the D, E, F are just the turn of this page. It just seem like A, Z, B and D, Y, E. So their lengths and the weights are same. Now from the figure it is clear that AC is equals to AZ, which is equal to 3, and CB is equal to this CB. When we fold this page, this is equal to ZB is equal to 12, and similar DF, this D and F, this will be equal to DY, and EF is equal to this EF is equal to EY, which is equal to 5. Now we find the values of the sides of the length of triangle ABC and DEF. Now find the volume. Now find the area of the triangles. From the figure it is clear that this area of the triangle half length into height. We know what is length and height. Putting these values is we get for the triangle ABC we get the answer 18, and for the values of DEF 2 multiplied by 5 divided by 2 is equal to 5. So area of this triangle and triangle B plus area of triangle DEF is equal to 18 plus 5 is equal to 23. This is required answer. This is very easy, but we have to understand, we want to understand the diagram that what is representing here. So I think you may be clear what is the how can we find these values, how can we find these are nothing. I just see you again, these are nothing, it's just a fold, nothing else, it's just a fold. When you turn back, when you turn back this triangle ABC, then is complete this then it complete this page, complete this page, then it becomes appears like a rectangular, complete rectangle, shaded rectangular W, Z, Y and X. When you return the triangle ABC and the DEF, it completes. So it means that these are these parts actually. So I think so, I hope so, I hopefully you must be clear, you must clear how can we find these values. And the next question is that find the area of the triangle TBC. If B is this, C is this, and the T lie at x is equal to 7. So first of all, what is first step? First step is that we have to find the coordinates of T, then find the sides length of the triangle, and then find the area. First, taking the first steps, let's move to solution. Given that T lies at x is equal to 7, this implies that it is a parallel line to y-axis. X is equal to 7, it means that it is a parallel line to y-axis. So this implies that for all at x is equal to 7, just y coordinate just varies the y coordinates, but x component of each point of the line at x is equal to 7 is constant, whose value is 7. This implies that at the place of y component of T, at the place of y component of the T, all the values of the y-axis are possible. It means that it is clear because T lies at this line. So this implies that its y component maybe may be from may possibly all the values of y-axis, any one of the value from y-axis, but x component is fixed, whose values is 7, because at x is equal to 7, the component of each point of x is fixed, which is 7. So we take an arbitrary value for y component, then we take an arbitrary value for the y component of T, which is equal to y, simply y, and x component is fixed. We know that at x is equal to the line at x is equal to 7, all the points as the x component is 7. Now we have to find now this is the T coordinates. Now find the lengths of the list of all the points. First we list all the points B, C, T. Now we find the sides length of the triangle. First we find the length of the triangle TB. This implies that 9 minus 7 plus 10 minus y whole ka square root, and open this square, and 9 minus 7 is equal to 2, and square root of 2 is square of 2 is equal to 4, and open this square, and square of 10 is equal to 100 y square minus 2 multiplied by 10 multiplied by y, and simply 104, 100 plus 4, 104 plus y square minus 20 y. Similar TC, this T and this C, 9 minus 7 is equal to 2, 2 4, 0 minus y, positive y square, square root BC simply, which is equal to 10. Now list all the lengths of the triangle. Now this is the stage we don't know which one of this length is a hypotenuse of the triangle, which one of the length is the base of the triangle, which one length of the which one length is the perpendicular of the triangle. It depends all to it depends a big it just because of the component of y. It just because of the y, because y here is arbitrary. In the above slides we say that y may be any value, y possible all the values from y axis. So we put here for y is equal to 0, we get the values of these length at y is equal to 0 tb. Putting the values of here 0, this term is 0, this term also 0, 104 ka square root, this will return as it is, and here put 0, this is 0, 4 square root of 4 is equal to 2, and now we get these lengths of the sides of the triangle. Now we use the Pythagoras theorem. Hypotenuse square is equal to base square plus perpendicular square. We choose this possibility, like this possibility it sets. So if it satisfies, it means that this it means that TB is a hypotenuse, TC is base, and TB are the perpendicular. So we putting these values. After putting these values, we see that this it satisfies the Pythagoras theorem. So this implies that TB is the length of the hypotenuse and others are the length and the width of the triangle TBC. So now we identify that which two values are the length and the width. These are 2 and 10 are the width and the these are width and the length of the triangle at y is equal to 0. So the area of the triangle is 10. You possible maybe you take these values, TC this value and DC this, and product them and then multiply by 5, then we get the answer 5 multiplied by this area of the triangle for all the values of y. This answer we just find the answer for a particular value of y at y is equal to 0. You can write in the general way. Now we list these values B, C, T, B and T, C. Now this is the moment we don't know which one of these is the hypotenuse, which one of these is length, which one of these is the width of the triangle. So since it all depends on y. So as we know that y may be from at the place of y we can take any value from the y axis. So at the y axis it is a complete real number. So we take a trivial case which is equal to let's say y is equal to 0. What happened? We get the values of TB is 104, TC 4, this becomes 0, this becomes 0, TB is equal to 104 square root 104, and TC this is 0. We retain here is 4, remaining is 4 square root is equal to 2. So BC as it is 10. Now we use this flow. We use this possibility. If TB is the hypotenuse and these two are the length and the perpendicular, then it satisfies the left hand side. The answer of the right hand sides are equal. If it is whole, then it implies that TB is the hypotenuse. TP is the hypotenuse and the other two are the length and the width. Then we use the other two are in the formula of the area of a triangle. So first of all, now putting these values, TB is equal to 104 square root of 104, TC 2 and BC 10. This is 4 plus 100, 104. Left hand side is equal to right hand side. It means that Pythagoras theorems hold. This is a Pythagoras theorem. So this implies that this term is a hypotenuse. This implies that TB is the length of the hypotenuse and others are the length and the width, and other twos are the length and the width. Now we identified the which twos are length and the width. So these twos are the length and width. BC and the TC are the length and the width. So the area of the triangle is equal to 1/2 length into width. So putting these two values, because this is a hypotenuse, we cannot use this, we use the other tools, because other tools are the length and the width, and multiplying this we get the answer this. Next question, the diameter of a circular shell is 2500 nanometer. Nanometer is a physical is a physics term. Nano means 10 raised to power minus 9. It means that you have a 9, you have a 80 before, you have a point, 0 point, then you write 8 zeros, then 1. This means that nano zero. Find the area of a cell. Now we have to find the area. We just given the diameter. We know that the diameter is the twice time of the radius. First of all, we simplify. The diameter is equal to 25 multiplied by nanometer. Nano means that 10 raised to power minus 9. 10 raised to power minus 9, and meter, this is a unit. This is a unit. As we know that diameter of a circle is equal to 2 times of the radius of a circle, so dividing both sides by 2, we get, here is a 1, and we get 2 as a denominator of the diameter. Now putting the value of the diameter of the circle, putting its value, we get 125 to multiply by 50 multiplied by 10 raised to power minus 9. Here we get the radius of a circle. Now we have to find the area of a circle. So area of a circle is equal to formula of area of a circle, pi r square. Pi r square. So value of the pi, we know that it is a fixed 3.14, and the radius 1. Putting the values of the radius. Now we take the square it both terms separately, this separate and this separate. When you have any digits with the power like this with the power, then again we take its power like this again. Now here is a digits 10 raised to power minus 10, whose we have a power, whose power is already in taking, that is minus 9. Now we taking again its power, which is square. Then what will be, how can we solve it, how can we take its square? Its square means that minus 9 multiplied by this, you take its power multiply by 2, multiply by 2. If here is 3, then we multiply by 3 multiply by minus 9. So you know that minus 9 multiplied by 2 is equal to minus 18, and its square will be equal to this. You know it's and this is equal to its multiplication is equal to this. Now you know that minus, when we take it as a denominator, then its power will becomes positive, and other object you can you also seek in the very basic classes, that if the base are the same, then powers will then powers you can we can add. So this implies that base 10 and base 10 are the same, so powers add. 12 plus 6 is equal to 18. This implies that 12 the power of 12 18 is equal to, we can write it as 10 raised to power 12 multiplied by 10 raised to power 6. So now we take it separate, 10 raised to power 12 as separate, and 10 raised to power 6 in this. And when we divide 10 raised to power 6 means 1 plus 6 zeros with 1, and multiply by 1 over 10 raised to power 12. When we divide it, it's then 4 point, we get the answer this, and the multiply by take it as a numerator, then its power becomes negative. So the answer is this, which is our requirement. Question: in the diagram, O is the region, PTS is a straight line, and TR is the parallel to x-axis. TR is a line that is parallel to x-axis. It means that at all this line, the y component is fixed, and the x components are varies. X components of different for all the points of this line are different, but y component, which is 3, for all the points are same. Since we know that as it is clear from the figure that T also lies at this line, so this and this is the parallel to x-axis, so this implies that the y component of T also is 3, also 3. And now we have to find the x component of t. Why we need to find the components of t? Now read rest of the statement of the question, which is S is a point this and R is a point this. Find the area of triangle RST. Actually we have to find the area of triangle R, S and T. That's why we have to find the coordinates of T. So the y component of the T is 3 because it lies at this line, and this line is a parallel to x axis. That's why its y component and is fixed, and the y component is given here because R is lies at this line, and the y component of R is 3. So this implies that at all this line y the value of y is at all this line the value of y is 3. Y is 3. This implies that value of y component of t is 3. So now we have to find the value of x. To find the value of x component of t, we must find the equation of line of ps. So first we find the equation of line PS. S is here, and this is also given 5/2 in the statement. Using the formula, this is a point slope formula through which we can obtain an equation of line, and where x naught and y naught and x naught are the coordinates of S, are the coordinates of point S. So y naught is 0, x naught y naught is 10, x naught is 0. So putting so this implies that y minus 10 x minus 0 is equal to 5/2, and after simplification we get y is equal to 5/2 x plus 10. Since TR is a parallel line to x-axis, this implies that y coordinates of each point of this line is same. This all the words that I described from the figure U already. This implies that value of the y component of t is equal to 3 because the value of the y component of r is 3, and also r is lie at the line tr. To get the values of x coordinate of the t, put y is equal to 3 in equation number 1. We have, because t lies also at this line, so that's why we can find the other the second coordinate of the t from here by putting the y value of y in this. So putting the value of y here, now move 10 from right to left, then its sign becomes change. Negative 10 plus 3, that will be equal to minus 7. So multiply by 2 from both sides, and this 2 becomes cancelled, and this is equal to minus 14. And now dividing by 5, x is equal to minus 14/5, which is equal to minus 2.8. So the components or coordinates of the t we have find minus 2.8 comma 3. Now the value of t is this, and the given that this is given in the statement, the coordinates of s and r. Now find the length of rt. R is the final position, so the x component of r minus x component of t, which is minus 1 plus 2.8 square plus square of y component of r minus y component of t, which is equal to 0, and so final answer is 1.8. Length of rs, s is the final position, so x component of x component of s minus x component of r 0 plus 1 plus y component of s minus y component of r 10 minus 3 ka square root, which is equal to square root of 50. Now we are able to find the area of triangle RST, the length of TR, length of RS. Putting these values, we get the answer. This is our required answer. Thank you so much.